Our final discussion on strain is to talk about how we can relate strain back to stress with a generalized Hooke's law. So I have here my block, and I have stresses on it, and the X, the Y, and the Z. And I've gone ahead and put these in the positive orientation. So if I want to calculate my strain in the Z direction, epsilon x, I would say epsilon x is equal to the stress in that direction divided by E, the modulus of elasticity. So this is like the one-dimensional stress relationship. However, if we don't just have sigma x and we have sigma y and sigma z, we learn that sigma y, as it pools, is going to cause contraction in the x direction. Think back to the Jello cube and Poisson's effect. So as we pool on that, it's going to shrink in a little bit. So epsilon x is not just equal to this value, but it also has some strain due to the strain in the y direction, so sigma y divided by E. And then we said it's contraction, and we relate it using Poisson's ratio nu. Likewise, epsilon x is related negative nu epsilon z, which again, epsilon z is sigma z over E. So now I want to take these equations and I want to write one general relationship for epsilon x. So epsilon x is equal to, we're going to factor out 1 over E out of everything, times sigma x minus nu times sigma y plus sigma z. So I think this equation captures this plus this into one format. Likewise, we can write the relationships for epsilon y and epsilon z just by switching sigma y with x. And we'll write epsilon z as such. All right, so I just want to, again, remind you of that Poisson's effect, especially when we're talking about things like plane stress. We need to make sure that our strains include Poisson's effect when we have other stresses in the y and z directions. Shear strain, we also can look at the relationship between shear strain and shear stress. So shear strain is gamma xy. We said that that is equal to the shear stress divided by the modulus, but now the shear modulus. So that's going to equal tau xy divided by the shear modulus. One of the interesting things with shear stress to shear strain relationship is that shear strains are only developed whenever we have shear stress. So if we only have normal stress, the normal stress affect all the different strains in the x, y, and z, the normal strains. But normal stress doesn't affect shear strain, and only shear stress in that direction affects shear strain. So we see gamma yz would then just be tau yz over g, and gamma xz would equal tau xz over g. All right, so that is basically the relationships for shear strain to shear stress and normal strain to normal stress. So it's important that we capture all of this, and we're going to use some of this in developing a failure theory of Amice's failure criterion in our next lesson. Oh, I hope you had so much fun today talking about strain transformation, de Moivre circle in 3 dimensions, and ultimately developing the generalized Hooke's law. It's just so great. I'm sure you're thinking that you're just knocking on heaven's door. Knocking on heaven's door.